All right, so now we're gonna look at continuity among a function. And basically, when a function is continuous, that means there's just no breaks, no stops, no holes, no asymptotes, no nothing when it's graphed. And the complicated reasoning is like when there's a y value at any given y value, the limit of that x coordinate has to be the same in order for it to be continuous. They both have to exist and they both have to be the same. So just complicated way. The best way is just think about it. There's no breaks, no stops. It's just straight going through. Not straight, but it's just no gaps, no nothing going through. Now, if there is a discontinuity, it's discontinuous. There's two types of them: removable and non-removable. Basically, removable ones are there's just a hole, and if you remove it, then the function will be continuous. If we take out this hole, go put a straight line through it. Hey, it's continuous. Now, non-removable discontinuities, there's two types: a jump and infinite discontinuity, and these are ones that we can't remove. In a jump discontinuity, sounds what it pretty much it is what it sounds. It jumps from one value to another value among the at one x point, right? Jumps to a different y value. And now infinite discontinuity is when there's a vertical asymptote and both sides go to infinity or negative infinity, positive infinity, and it breaks to infinity. So how do we figure out if something's continuous or discontinuous, and how do we figure out which it is and at which point, right? That's what we're trying to figure out here. And so if we look at the first one, think about it, right? 2x squared plus 5 is just a parabola. It'll go straight through. So that means it's continuous because there's no stops here. Next one. Now keep in mind that the denominator can't have zeros, right? So because then it's going to be undefined, right? F of x is going to be undefined. That means that point doesn't exist. So at which x points is it undefined? Well, let's simplify this out to x over x minus 4 and x plus 4, difference of squares. And that means at x is equal to negative 4 and 4 is when f of x would be undefined. So those are our two discontinuities. And how do we figure out which discontinuity it is? Well, because nothing can get canceled out from here, that means it's non-removable because we can't remove anything, right? So that means it's a non-removable discontinuity. Okay, that makes sense, right? Now, let's look at number 3. This one, x minus 4 and x, we're going to factor it out. Boom. Okay, so it's still negative 4 and 4, but negative 4 can be positive 4 can be canceled out. That means our positive 4 is a removable discontinuity, while our negative 4 is a non-removable discontinuity. Number 4. This one, when x, this one, in order for the bottom, let's take a look. Gonna write this down. Notice how if we factor this out, your x plus 1 can be canceled out. That means there's a hole there. But here's the thing, right? We know that there's a hole there when it comes to this one here, but what if that hole is filled by this negative 2 here? So we need to figure out what the coordinates hole is going to be. What the hole's coordinates going to be. Sorry. So basically what we're doing here is we're going to cancel out our x. We're going to cancel out our hole. And we're going to get x minus 1. And then as x approaches negative 1, of x minus 1 is equal to negative 2. That means the hole is existent at negative 2. And so that means when x is equal to 1, this negative 2 perfectly fills up the hole. and therefore it's continuous, because even if there's a gap here, where that gap is, this number perfectly fills up that gap, which is just super cool. All right, this one is a little more complicated. So we just have to worry about this -1 and 1 basically when it switches functions, because each of these are continuous functions. That means we know there's not going to be a discontinuity there. We just need to worry about the switches between them, right? So first we're going to look at x is equal to -1. And that, remember, we have to, in order for it to be continuous, both have to meet at the same point, and they have to be, the limit has to be the same, right? So the limit as x approaches -1, we'll say from the left side, we're going to use this function is equal to 1. Okay, limit as x approaches -1 from the right side, we're going to use -x squared is equal to -1. And because they don't equal each other, right, that means they're jumping. It's a jump discontinuity, right? Next one. X is equal to -1. Limit as x approaches 1 from the negative side of -x squared is equal to -1. Limit as x approaches 1 from the positive side is equal to also -1. But here is the thing, is f of 1 does not exist, because if we look at the problem again, this is a less than, this is a greater than, but there's never a equal to sign. So that means although they meet at the same number, there's going to be a hole there, because at x equals 1, there's not actually a value there. So there's going to be a hole there. So that means there's a hole at x is equal to, sorry, this is supposed to be +1. There's a hole at x is equal to +1, but it's continuous, but it's a jump on x is equal to -1, which is pretty interesting when you think about it.